What's up guys, welcome back to the MSR Workshop. So today's video we're going to be doing an unboxing from a company called WIZMAKER. Funny sounding company, but they sent me a 12-watt diode laser for review. Now I've heard this company also offers a desktop CNC machine that I may or may not decide to review in the future. But today we are going to get this 12-watt diode laser unboxed. We're going to check it out and see if this is something that you want to spend your money on. So stay tuned. So this little 12-watt laser was sent to me by a company called WIZMAKER. Now, normally I have been backing off on reviewing diode lasers just because there is so many different ones on the market. And really, companies like Xtool has kind of cornered the market with diode lasers and what diode lasers can really do. And they've kind of pushed the technology into realms where you have combined multiple diodes to make a really big, powerful single unit laser. Now, talking about diodes, when WIZMAKER first reached out to me, they wanted me to test their little 4-watt, I believe it was, don't quote me on that, diode laser, and I wasn't really interested, just because everybody is starting to combine multiple diodes into one large unit just to really give more powerful units. So a tiny, small powered diode laser was not something that I would find very useful. Now, when they came back and said, would you like to try our 12-watt? I would say, sure, I'll try it out, just because that is a little bit more usable, and anybody that's starting in the laser market, I recommend getting a more powerful diode. Don't start with the least powerful one. Now, diodes themselves, the maximum power that you can get on an individual diode is close to about 6 watts. So how these companies are getting higher powered ones is they're combining multiple diodes in one housing unit, something like that there, and then they're using mirrors to focus them all, getting 30, 40, even 50 watts all in one housing like this. So this being a 12-watt, there is probably 2 diodes inside. So looking at the manual briefly, sorry, I'm starting to rant. It is quite a large manual, but it looks like it is covered in, multiple different languages. You have some color pictures in here. You even actually have some sections on using Lightburn, which is kind of cool and unusual because Lightburn usually is a third-party company that does not come with the machine. Okay, so interesting. Right away, looking at part of our frame here, that frame is made out of some sort of plastic. Bottom rail is aluminum. Top rail there is made out of plastic. And then you have a guide bearing system similar to what you would see on a 3D printer. And then there's your stepper motors there. Okay. Same kind of an open back. Don't know if there's a housing for that or not. But we'll keep putting it together. Got all your little goodies and screws, put everything together. Power cord. All important safety glasses. Here is your laser module. This is plastic. And it's open in the inside, which is not something I'm used to seeing. Usually these units are all completely closed up, and then you just have your laser head poking out the bottom. So that could be interesting. We'll see. All right. Next layer in here, you have another belt drive with another motor on it. Next, you have your other side, and this is where you have your on-off switch, your USB, and then a USB-C to connect to your computer. I do like the fact that they've connected a USB-C to it instead of just a standard USB, because more and more things are moving to USB-C, but it is a little bit harder to find long-range USB-C. I mean, obviously you can get them on Amazon. Rod, I'm assuming, to connect both sides. And is there anything else in here? Nope. Okay. So, found everything out in there. Go ahead and set that aside. And put this together. So that is open down there. You can see some of the electronics. That is not sealed up. So, got to keep an eye on that. Make sure you don't get debris or hit that. Looks like you've got an included memory card of some sorts. It does not say anything about it, but we'll just go ahead and leave that in there, but I'm assuming it is for the software to make it work. A little extra length of cable. M5 screws, Allen wrenches, and a little tightening. This is going to slide on if I put it on right. And that's where you adjust your height. So that will fit in right there. That will fit in right there. And then this is going to screw in the end. And all of these large screws look to be the same. So one screw on that side. This is a little bit cheesy how it fits together. And you kind of have to put a number of things together before it bolts together. Okay. And if you're not a retard like me, you put this the other direction. So I'm going to pause and flip this around. I will be right back. Now let's go ahead and install our cabling. So one thing you also want to make sure of when you put it together is that these connections are coming to the same side as your cable on the front panel, because otherwise they won't connect. So you have this style plug, which is right on the side of the machine. That'll plug right there. This one will plug right into that motor. And they should snap right in. Then we have one for the top of the machine. Those should plug right in. There we go. And last but not least, we have our final connection to our motor there. Then you can start tucking your cables in. I would slide this all the way to the side and make sure your cable can just pinch right into those cable connectors. Being careful not to push too hard on these because these are plastic as well. And if you snap them, then you are fresh up the block. So that is it for assembly on this machine. Now we're going to go ahead and unwire this USB-C cable. Hope it's long enough for my connection to my computer. And we're going to go ahead and plug this in. So I'm going to relocate this over to a honeycomb bed on my large laser, just so I can have some sort of exhaust while I'm doing this. Now, looking through all of this here, one thing that I don't see, which is pretty critical on a lot of these machines, is setting up the height of this. And a lot of times, like every time actually, I have seen a block. Nope, I take that back. Okay, well that's cute. So in this machine right here, we have a little knob. You turn it. This is your height for your laser. Once you've set that, you turn it back. So that's kind of cool. It's got it built in for you. Turn, set it, go. All right, let's get this over to the honeycomb bed and connect this to Lightburn. Okay, so now is the part where we go ahead and connect it to Lightburn. So I'm going to turn my machine on, see if it homes or see what it does. Didn't do anything yet, so let's try this. So we're going to go to Devices, find my laser, and we'll hit Next. See if it comes up with anything. If this doesn't work, then we will just manually create a laser. Okay, so it did not connect and I had to restart Lightburn because it locks up sometimes. So the next way to do it is we are going to create our own device. Now this is running on a GRBL type controller. So we're just going to go here to create manually. So let me back out here. So you're going to go to Devices, Create Manually, and then you're just going to pick GRBL from your list here and hit Next. Next, we're going to use serial USB, and then we're going to type in our bed dimensions. Now, from the scale on the side of this machine, it is a 300 by 300. So 300 by 300, and we'll hit Next. We are going to home from the rear left, where is standard with most of these machines, and hit Finish and hit OK. So now we're going to go ahead and select our machine from our drop-down menu. And it should, in theory, automatically home. And it just did. If it doesn't do anything, go to this middle thing here, and you're going to select USB serial 240. It may show up to something different, but just choose one of these two here, and your machine should do it. Now, sometimes machines are a little bit quirky in the fact that unless this is selected before you turn your machine on, it may not home. So one thing to do is select the appropriate ones, then turn your machine on again. So turn it off, turn it back on, and see if it will home. So next is these guys here. Now we are running off of millimeters per minute. And so these speeds are going to be set to very high. So you can set your speed to 6,000, your Z speed. Actually, that's an up. Yeah, you can set that to 6,000. Usually it's going to be an X and Y. I'm not sure why Z is showing up here. And then your Z distance. Just leave that alone. So it's not going to do anything. So the distance here, when you set it, is going to be based off for these. Now, if you don't have anything set up here, I mean, you can push 1, and it's only going to move 1 millimeter every time you click it. If you want to do bigger clicks, move like I don't know, 30. So when you click it, it's going to do a 30 millimeter move each time, left and right. If it's set to 0, it'll pop up with a saying no distance set. So this can be customized each time. So if I go and click this little guy here, this is where I can set my origin for clicking on the screen. So I can click, say, dead center. You hear the machine moving. It should automatically home to dead center here, wherever I click. Anywhere I click. So next, we are going to start by just making a little bitty square. And that's the way you drive the square tool and create a square. This is a 100 millimeter by 100 millimeter square. And then you can highlight it and move it around wherever you want. And now we are going to test this out, see if this thing fires. So next we're going to go to my cuts and layers. And this is in Lightburn. I don't bother messing with any other program but Lightburn. So if you want a laser, first thing is go out and buy a copy of Lightburn, and you will not regret it. I will not be testing anything that doesn't work on Lightburn, nor will I be using any factory manufacturer's programs. Lightburn, just use it and you'll thank me later. So we're going to go ahead and click on our power settings and speed. I'm not sure what the manufacturer's max speed on this is. Console. I'll look through my manual and see if it says it somewhere. Go up here to your little picture of a wrench. Go ahead and click on it. Go to additional settings and then hit read from controller. So now we're going to have all of our speed settings previewed here. So our maximum speed is X is 166. Y is 166.7. That seems awfully slow. Let's do some cutting. So first test piece is we are going to be test cutting this. I don't know if I would call it Baltic birch plywood because it's not. It's some other type of plywood, but it is a 2 mil thick plywood. So we're just going to go ahead and put that in there. Next, we're going to turn our little knob to 0 it, and we're going to drop that all the way down, tighten that, and turn our knob back. And so now, in theory, we should be zeroed out. We're going to start at 50% power since this is a 12-watt laser, and we're going to frame it. Then I'm just going to go ahead and move that underneath. Now, one thing to take in mind is this does not have any form of air assist on it, so you will get more smoke and everything. So I'm going to go ahead and turn on my exhaust, and we're going to hit start and see. So we are going at 600 millimeters a second. Actually, that's going to be way too fast. Let's bump this down to, actually, this is millimeters per minute. Let's just leave it at 600 and see what it does. We're just going to go in 600 millimeters a minute and 50% power and start. Well, it made a little line. Absolutely did not go through. But line looks decent. These sides are a little bit thicker than the bottom and the top. Don't know if that's just the wood, but we'll go ahead and try that again. We are going to slow that way down. So we're going to go down to 100. And we'll try that. Ooh, that's really slow. And it is nice. You do have a little bit of window that you can see. 50% power and 100 millimeters a minute. Did not cut through, lots of charring, a lot of burning there. Let's go ahead and put that back up there. Let's bump our speed up to 200, and what the heck, let's just go to 100% power at 200 millimeters per minute, and we'll hit start. Well, making lots of smoke here. Oh, look at that. We actually cut through that in a single pass. Fair amount of charring here, so we probably could bump our power down. But this just dropped right out. So let's try that again. Let's bump our power down, see if we can't get a piece that is not quite as charred. Let's try 70% power and see if that'll go. Well, it looks like we just barely broke through. Still a lot of charring. Had to push that one out. And I'm pretty sure 80% would have gone through. But messing with settings, definitely. So that's a pretty good thickness of wood. Let's go ahead and try a different thickness here. And we're going to jump it up, or jump it down, to a 1 mil. So we'll go ahead and leave that at 70% power. Throw it back up to 600 millimeters per minute. And see if it cuts through this 1 mil piece of Baltic birch ply. So that did not do it. That was just too fast. Let's go to 300. Just a little bit showing on the back side. Not quite there yet. Oh, you know what? One thing I forgot to do, guys. I forgot to reset my laser height. Of course, my wood is a little bit warped, so that may make a difference. Let's try another one. So it's burning, you can see that, on this direction, but this direction, it's actually changing power just a little bit. Very interesting. Let's go to 200, leaving it at 70% power. And that one fell right out. So that is about the perfect setting for that one on 1 mil Baltic birch. And as you can see, very little charring at all. I don't have any soot on my fingers much at all. So 70% power, 200 millimeters per minute, and that seemed to have done a great job. Now let's go ahead and try some engraving. All right, so going back up to Lightburn, we're going to try an image of Deadpool here in grayscale. Here's where we're going to pick our image mode. So depending on how good you want it to look, 600 dpi is probably great. Let's go to a grayscale. And so we're going to find our image mode here, grayscale. And we need a minimum and maximum power so you get that effect. So we'll go down to 10% here, and I don't know, 90% up there. We're going up to 90,000 millimeters per minute, 600 dpi, and it's just going to go back and forth, which is called bidirectional scanning, and hit OK. All right, guys, so let's take a look and see how this turned out. So looking closer at the artwork that I grabbed for this, it actually turned out to be just like somebody's line drawing. So let's see if this will focus here. There we go. Sorry for my weird shadows. So overall, not too bad. I did have to stop at once and redo this because I had my dots per inch too high. 600 is way too high. It actually was really burning the wood, so I dropped it down to 300. But getting accurate grayscale or picture engravings are pretty difficult to do, but this actually turned out pretty decent. Got a little area right in here where you got some lines, and that could just be in the person's artwork because this is a pencil drawing. But I think you can see what this is. Machine's a bit slow. That's my only complaint with it so far. But yeah, if you speed it up, obviously you're going to get a much lighter engraving, and then you tweak the settings, so you can only go so far with 12 watts. So two of my next tests. Next, we are going to try and cut some leather out, and this is a 1 mil, maybe it's a little less than 1 mil thick piece of leather. Throw that up there, and see what we can do with that. So I am just going to, for fun, draw just a little bitty square. We'll throw the letter A inside. So the A, we can engrave it, and then the square will be used to cut out. Okay, so first to do this, we're just going to go, let me get my light burn back up on screen. And so I've got my box with my little A in it. I'm going to change the color of the A to blue. That's how I can separate out my cuts. Come over here, cuts and layers. So my black line is going to be a line. My blue is going to be a fill. And I want to change the order. So I'm just going to click on my black line and arrow down. So I want to fill first, which is going to be my blue, and my black is going to cut it out. So my fill, I'm just going to guess on the settings. We're going to do the 6000 again, and don't need it to be super dark. Let's go to 30% power and 300 lines per inch. And just for fun, let's do a cross hatch pattern that goes left and right and up and down to give you a little bit higher resolution. And then my cut settings, we're going to go to, we'll do that 300 like we did before, and we'll try 70% power. That may be way too high, but yeah. So let's frame that. Turn my exhaust back on. Alexa, turn the exhaust on. And we'll hit start. All right, let's see if that cut through. So that did not cut through at all. My engrave settings looked good, but my part there did not go through. So let's try that again. So line, we're just going to drop that down to 100 millimeters per minute, same settings, and start. All right, let's take a look at that one. So it did the A, but as you can see, it charred it. So it is possible to cut through it. You're going to have to mess with the settings a bit to get it to work right. But for light engravings on leather, it will do a pretty decent job. Next, we are going to try some rubber. Now, this is just a hair over 1 mil, but on my other laser, I was not able to cut through that at all. And why would you want to cut through and do rubber stuff? Well, you can actually make like rubber stamps and do some fun stuff with that. So we are just going to try our small square, and let's bump our speed down. So we got it at 100. Let's bump it down to 50% power, see if it'll cut through. And start. So almost cut through. Of course, it's melting the rubber. And the big thing is you don't have air assist on this style of laser. So with the air assist, it really helps clean the cut. It also keeps your material cooler. We'll give it one more go. Let's bump our power up to 70% and see if we can keep it from starting a fire here. And start. Got a little bit of flame in there, but I've got a fan that actually blows down, so it looks like it's helping keep any flame that creeps up away. So 70% power did not make it through, but if you're going to have to cut something out, you could just tear it the rest of the way, unless you just had to have those perfectly clean lines. All right, guys, let's talk about the WIZMAKER 12-watt diode laser. It's an okay little laser. I don't think it's the best that I've seen. Complaints with it, it's got a plastic frame. Yes, the side rails here and here are metal on the top. These are plastic. It does feel kind of cheap. Everything is kind of open. It does cut, and you can use it for projects. Is there better options out there? I will let you be the judge of that. I think there are higher wattage options available that might suit more people and be suited for a wider variety of projects. Now, that being said, WIZMAKER did send this to me for free, but my opinions are my own. But I will leave a link in the description if you want to check them out more, or if you're interested in, say, something like a desktop CNC machine, which they do offer, which I have not tried. I know that is on their website as well. But if you guys have any comments, questions, or suggestions, or if I left something out, be sure and leave those in the comments below. And until next time, guys, thanks again.